Diagnostics for intermittent problems can be some of the most challenging diagnostics for a technician. Why? To solve a problem, the technician must replicate the condition. It is a challenge for stop-start starters because accelerating and braking are essentially an intermittent condition controlled by the driver. But there is a madness to a stop-start system, and they are called preconditions. Stop-start technology is more than just a switch wired to the brake pedal and starter. It is a function of the power management system that uses several modules to decide when the engine needs to stop and start. On all stop-start vehicles, the life and performance of the battery are measured by the vehicle in several ways to meet specific preconditions. These constant checks prevent the engine from being stopped and the battery not having the power to restart. Some manufacturers call it a battery or power management system, but whatever its name, the system's goal is to balance the load on the alternator and battery. Most of all, these monitoring steps prevent the customer from being stranded. The next set of preconditions is about emissions and performance. Stop-start systems require the engine and engine management system to meet specific parameters for closed-loop operation, engine temperature, and other emission monitors. This strategy gets the engine up to temperature faster with less emissions. The last set of preconditions is driver comfort. You may not think that the HVAC system would be connected to a stop-start system on a vehicle, but even a cabin temperature sensor can deactivate a stop-start system. All stop-start systems are designed to not inconvenience the vehicle's occupants by causing the interior to be too hot or cold. The most exciting part of a stop-start system is the relationship between the position of the crankshaft and the engagement of the starter. These starters operate the same way, but with some critical internal differences. The first thing you will notice is that the gear on the starter is larger and the gear reduction system is lower. This allows the starter to turn slower, which reduces wear on the brushes and bearings. Also, the armature and brushes are upgraded to improve the longevity of the starter. The solenoid on top of the starter is a little more complex. These solenoids might have an extra connection or two. The fork of the solenoid has better control over how the pinion makes contact with the ring gear. These systems will engage the pinion when the engine speed drops to below 200 RPM. The pinion will stay engaged until the engine is restarted. This eliminates the clashing of the starter when the driver pulls away from a stop. Also, the engine starts faster. The one item that makes this lightning-fast engagement possible is the crankshaft position sensor. By knowing the position and speed of the engine, it can make for a less intrusive start. When diagnosing a stop-start starter issue, some of the best information you can find is in the repair information or part of a TSP that lists the preconditions. These typically cover mundane items like doors and hoods, but will also cover specifications like engine coolant and HVAC duct temperatures. Thanks for watching.